right. So you've built a deep background that sort of led you to Verijet. So talk a little bit about what Verijet is, because we really haven't talked about that, and how you got to this point and sort of where you are. Just kind of tell me the story of Verijet, the founding of Verijet.
Sure. So in the background, I'm going to run some video from one of our proving flights. This was for our lead Series A investor between his factories. This happens to be in Minden, Nevada. And this plane is so quiet that at this distance, at this approach, you can't even hear it. It solves a noise issue. It solves a carbon footprint issue. But backing up here, we're routing all of these fleets of aircraft, the best floating fleets in the US. And what I'm seeing is that flights under 600 nautical, where you can't climb high, so you're down at 18,000, 19,000 feet sometimes, are being served by metal planes that were designed in the 60s and built in the 80s. So when you pressurize a metal plane, you're losing cabin life, the airframe. Every time you pressurize it, there's metal fatigue. Think Aloha Airlines and a flight attendant sucked out in midair.
Right.
Or think the de Havilland Comet. It had square windows. The stress would concentrate in the corners. The airframe would blow apart, and every 3 months you'd lose an airplane. That's why the British don't have Lockheed or Boeing. It's because they had square windows versus round windows. We had round windows. So metal fatigue is serious. It's still serious to this day. This plane that we fly is carbon fiber, no metal fatigue issues. So we can do short hops. We have a single engine that's radically efficient, designed for lower altitudes. When Cirrus first premiered this jet, they talked about the lowest and slowest jet because it's efficient, radically efficient at low altitudes. So we picked the sweet spot of these 600 nautical flights. When one of our operators has a plane break, or when they're oversold the day before Thanksgiving, or whatever happens to them, and they have to outsource a flight, no one wants to fly a metal jet for a 30-minute hop. You have cycle costs on the engines, you have the metal fatigue, you have gear inspections. There's a lot of expense to flying a Citation 10 short haul. Yet people do it. We watched one fly from Santa Monica to Las Vegas, for example.
Yeah.
19,000 feet, 260 miles an hour, 280 miles an hour. So the other thing is down low, you can't go fast. So you have these big honking bird vacuum engines on your Citation 10 or your Challenger or whatever it is, and they're gobbling enormous amounts of fuel because they can't get high to be efficient.
Right.
Conversely, we're single engine, single pilot. We can do these hops extraordinarily efficiently. Now, here's the killer. When one of my carriers outsources one of these, they have a 2-hour minimum, $4,500 an hour, $9,000. We can do that flight profitably at 50% EBITDA for $2,500. That's the differential. Okay. And it's a number of things, including just the low altitude performance of this single engine jet. Okay,
that's crazy. And I think that you've got just a tremendous opportunity there. So talk a little bit about the timeline, if you can, on where you are with Verijet and when you expect maybe to have the first paying passenger, if that's something that you could share.
Certainly. So this is, first of all, a 25-year project. It starts at Danville, Virginia, with the Small Aircraft Transportation System, which is a NASA project. And let me give clear credit to NASA. They realized early on that hub and spoke didn't make a lot of sense. We took 500 mile an hour, amazing pieces of technology, and reduced our average travel speed back to 75 miles an hour. Hub and spoke. This is even before 9/11. Post 9/11, it's clear cut.
Yeah, let's dig into that a little bit more, because that was one of the things when I met you and I saw your presentation at AirVenture last year. I think that slide to me was the one that was like, man, this is a no-brainer, and it's sort of ridiculous what we've done. I don't know if you've got that slide, but talk about that slide that shows basically where we've come as humans in the United States from a travel perspective, from horse and buggy to automobile to aircraft, and the speed we were accomplishing certain trips to where we are now.
So to parrot NASA, we're going to unlock the fourth wave of high-speed travel with this project. We went from horses to cars and got 75 miles an hour. Cars to props, 200 miles an hour. Props to jets, 500 miles an hour. Well, gone are the days where you can get to your flight 20 minutes before boarding and go. And on top of which, you're going to have to connect because a lot of the direct point-to-point service is gone. So it's back down to 75 miles an hour. Yet there's 5,400 airports we can comfortably use with a Vision-Jet. 98% of our population is 20 miles from one or more of those. So as a commercial instrument-rated pilot in the Southeast, I was flying to NBAA, our industry's trade show. Was in Atlanta that year, and I didn't know which airport to land at. Is Peachtree DeKalb closest to the convention center, closest to my hotel? And a light bulb went off. If a commercial instrument-rated pilot in my home region doesn't know what airport to go to, the general public has no chance. They have knowledge of about 29 major hubs, and that's about it. So we have a patent on booking of air travel by street address, which helps you identify with drive time the closest airports. That is simple sounding, but it's key to unlocking this. Another key is getting the passenger to the FBO rather than the main terminal.
Right.
That's maybe the most logistically difficult problem. So you dispatch an Uber with the correct address, and that solves that part. But basically, this becomes about point-to-point travel. Our average speed of travel gets to 300 miles an hour when you do this. Now, what's interesting, on these low flights, the average speed over the last decade is about 247 knots. You can take a Citation 10, beautiful airplane, nearly supersonic at altitude, 247 knots. It doesn't matter because of speed limits and ATC. The Vision-Jet will do that and more down low, so we're not giving up any speed, but we are radically more efficient. Anytime you fly this versus the next most efficient light jet, you're saving a ton of carbon every 1.1 hours. But against a Challenger or a 10 at low altitude, it's 9 tons. It's 2,500 instead of 25,000.
And so when you're saying a ton of carbon, you're not exaggerating. It actually saves a ton of carbon.
A ton of carbon footprint, absolutely. Yep.
So, because sometimes people use a ton like, it's a ton of whatever, but no, you actually mean a ton of carbon. So I just want to make it clear.
Yeah, 1,800 pounds of carbon per gallon per hour. So 1.1 hours is a ton.
That's crazy. That's crazy. And so, so it creates significant value. And, that all goes to, I tell friends all the time that, we're in Pensacola, right? And if I want to go to Miami, on Delta Airlines as an example, you take off here and you've got, 20 minutes to the airport. Generously you're at the airport an hour ahead of time. You get on the aircraft, you fly to Atlanta, you wait another hour at least there, then you board and you taxi and you take off, and which is all why anyone with a Cessna 182 could beat that aircraft from Pensacola to Miami just by taking off and going direct by the time you get there. So your point about adding efficiency to air travel is great, and it's honestly, to me, it's a little bit we just haven't, a lot of people haven't thought about that. Clearly you've thought about it, but the inefficiency we sort of accepted as a traveling public over the last 20 years is kind of incredible.
We handicapped amazing technology, and NASA knew this, they saw it. So now add in something like Uber Elevate or William or a dozen of the startups that we're carefully tracking. But they could now take you from your downtown apartment to our airport. You can board your Vision-Jet, you can get to your destination. You can be there in less than 2 hours, back the same day, and you've never gotten into a traffic jam. I haven't talked much about it yet, but our Vision-Jet can burn 4 types of biodiesel. Williams certified that for us a couple of years ago, with no impact to maintenance schedules or cost. So that is phenomenal. And we're likely to be vertically integrated with a couple of Jet A biodiesel providers.
Okay, that's outstanding. All right, so talk again about timeline. I don't think we touched on that. When do you expect to fly your first passenger with Verijet?
So no later than October, November timeframe. And the uncertainty is FAA certification efforts. So we started last February, filed a statement of intent. All of our manuals and everything required for our op specs go in by May 1st. And as you can imagine, we're meeting with the FAA on Zoom. The FAA, the Orlando FISDO, they have been spectacular. Now, turns out half the time they were working from home anyway, based on the nature of their work. And because we're bringing the jets to them, there's no travel, so they've been able to continue. But in a time of COVID and disruption, it keeps you on your toes. We're fortunate that they are all in on the project.
Okay.
Have you seen the Safe Flight video by any chance, or the Safe Return?
I don't. Oh yeah, I have seen that on YouTube. Yes,
Yeah.
and that's the
So,
Garmin technology, right?
correct. Garmin and Cirrus and Piper, they worked on this secretly for 5 years. We met with the FAA on October 31st to get serious about this project. That's after waiting for the PASI. And the night before, Cirrus released the safe return video. So the first part of our meeting with the FAA was, what are you guys doing? Single engine. And I explained about single engine low altitude efficiency, the carbon, and they loved it. Because private aviation is taking a beating on carbon footprint. And you have Elton John buying carbon credits for the royal family and carbon shaming. And that jet example I gave you from Santa Monica to Las Vegas, they wanted to call the board of the company that owned that jet, that took that one passenger on that crazy, inefficient, expensive flight, and shame them. And I'm like, don't do this. I'm in this industry. Let's just give a better alternative. So the second part of it is single pilot. You want to fly commercial single pilot? Well, yes, because at the push of a button, the passengers can land the airplane under AI control. And when they saw that video, their world is, I want to take some used King Airs and some Citations and start a charter company.
Right.
And they walk you through the paperwork on making sure the carpet that was replaced a decade ago was fireproof, when repair stations only have to keep records for 2 years. So how do you prove that? Or, this rivet repair or whatever it is. I'm like, this is all great, but we're taking brand new carbon fiber planes right off an assembly line, putting them into production. And by the way, they can land themselves, and they had never seen anything like it. So it gives something interesting for the examiners to work with. We brought phenomenally experienced people. So our Senior Vice President Flight Operations, Steve Clemens, started as a co-founder of Virgin America, flew their first flight as a 777 captain, has 15,000 hours, and started 6 other operations after that. So we brought all of this firepower to the table, everyone on our side of the table. By the way, you have 5 representatives and you have 5 FAA examiners, and you sit on different sides of the table. 2 of us could have switched sides. I'm the lead safety rep for Palm Beach Martin St. Lucie in the FAST program.
There you go.
And one of our other folks was a FAST representative. And then even our COO, CFO did safety programs for a Piaggio turboprop operator. I have coded safety programs for companies like TMC. They've just not seen that level of experience with a cool airplane, with safe return, and it fixes the carbon problem. So it was a home run.
It's going to be amazing.